Or if you read the thing down here, for some reason, some people use MC for micro. We're not going to use MC for micro. That's just wrong. Okay? So I remember them as whole numbers because I don't like decimals and fractions. Deci means you have 10 per the unit. Centi is 100, milli is 1,000, micro is 1,000, a million. But I have to remember these are smaller. Okay? That's going to be important when we start doing conversions next week. Okay? So, their examples are a kilometer has 1,000 meters, a kiloliter has 1,000 liters. It doesn't matter what the base unit is. It's a big number. Now, have you ever seen these units used before? You probably have. If you look on most packaging these days, it gives your daily required allowance or recommended amount of all the nutrients that are in your food, right? On a package. And you can see, for some things you need a lot, and for some things you don't need much at all. Like, look at vitamin B12. How much you need for vitamin B12? 6 micrograms. I'm telling you, 6 micrograms is just like half a fleck of dust if you had all of it in one place. Okay? It's not much. But look at potassium. 3,500 milligrams. That's 3.5 grams actually. Okay? Where do you get your potassium from?
Bananas.
Why do you need potassium? What? Yeah, bananas is a high potassium source, but it comes in lots of foods like potatoes and stuff. What do you need potassium for? What do you use it for in your body? What? What'd you say?
Does it help rebuild muscle?
Not just rebuild muscles, but it is used in muscles, but it's used in muscle contraction and sending nerve signals.
So that's like you're potassium deficient, that's why you get cramps.
Amen. If you start to become low in potassium, you'll see lots of athletes eat bananas because they start to cramp. If you know you're going to exercise heavily during the day, you should eat a banana in the morning. It'll help prevent muscle cramps because the nerves are actually what's causing some of that. Highly important in sending nerve signals. Potassium. Okay. Some of the other things you don't need a whole lot of. Selenium and zinc. Don't need much. Right? Very little of some of the nutrients. But you can see the difference in the units on the packaging. So, now, these units also, you need to know the prefixes for. Okay? Kilo. I don't know if all of you know that.
Mm-hmm.
Somebody else's. They
In
lost
their ear.
one. So the prefixes tell you what that modification is. So 1,000 meters is equal to 1 what? You know? What's something big other than the basin? What unit did I tell you how to know that's a big unit? Kilo, right? So 1,000 meters is 1 kilometer. So every kilometer has 1,000 meters in it. Okay? Now, I don't like these decimals, right? I don't like it written like this. 10 to the minus 3. Anybody know what unit that is? Deci, centi, milli. Okay? That's 1,000. Milli is 1,000. So this would be 10 to the minus 3 grams is 1 milligram. I would write this one really as 1,000 milligrams equals 1. Equals 1 gram. Okay? Same thing here, 0.01 deci, centi. This is a centimeter. I would actually write this as 100 centimeters. It's acting weird because I was using that other program before, and it doesn't like that. programs are jealous of each other. 100 centimeters equals what? 1 meter. Okay. I would write them like this because I like whole numbers, not decimals like that. And that's going to become important as we move forward, particularly next week when we start doing some conversion. So, yeah. So here's we're talking about ophthalmologists, right? Ophthalmologists deal with eyes. Eesh. Eyes are kind of slimy. Anybody ever dissected an eye? The inside of it's like gelatin. The lens is cool, but the rest of it's kind of nasty. So you can measure the nerves, and you can see the different units are important, right? One of the most famous eye problems ever was, you might know what the Hubble Space Telescope is? Just go look it up. It went up into space, I don't know, 10, 15 years ago. Well, two different groups were working on it, and they didn't give them units that were correct, and so they built it wrong. The lens that's in the telescope was wrong. So they basically had to do another space mission to put a giant contact lens on the telescope. Because they didn't use the right prefixes when they were making them. Actually, for them, I think one was working in English units and one was working in metric units. And they didn't pay attention to the units. Okay? Here, they're talking about the retina being measured in centimeters and a nerve being measured in millimeters. You certainly wouldn't want to mix those two, would you? Okay? It's a factor of 10 different. Okay? So it's important that you get the right prefix on there. Volumes. Volumes are measured in liters, right? Oftentimes in the lab, we're going to use milliliters because a liter is kind of a lot. That bottle right there is a 1 liter bottle. Right? That's how much a liter is. You often buy like bottled water comes in like what? Half a liter now. They're starting to, in the US, we're starting to slowly switch over to metric, right? You go to the grocery store and buy a case of bottled water. Oftentimes it's in half a liter bottles. 500 milliliters, right? Is that 500 milliliters? Yeah. A little bit less than 20 fluid ounces. Okay. You can also have cubic units. Cubic units are when you multiply 3 units together, i.e. a cube. Define the volume of a cube, multiply length, width, and height, right? And when I multiply length, width, and height, my 3 units will be equal to, almost made it. Try not to be. Please let me just write one more M in a 3. It's not going to let me. All right, I'll just point it out. Centimeters times centimeters times centimeters equals centimeters cubed, right? Centimeters raised to the 3rd power. That means you're working in 3 dimensions, X, Y, and Z, right? Now, you guys will often see this abbreviated as CCs. Where do you see those CCs at? On a, what do you see on a, or on a syringe, right? Syringes often will have CCs written on them. CCs, in my opinion, is the incorrect abbreviation for centimeters cubed. It should be cm raised to the 3rd power. There is no base unit that's a C. Okay? It should be cm cubed, but it's the same thing. Okay? A cc and a centimeter cubed, because 1 centimeter cubed equals 1 milliliter. If you have 1 milliliter, you have 1 cubic centimeter of water. Okay? And that's what the next slide is showing. If you have a cube that's 10 centimeters on a side, this is 1 liter, and one of these little cubes right here is 1 milliliter. A milliliter is not a lot. right? Because there's 500 of them in that little bottle right there, and there's 1,000 of them in that neon fluorescent bottle over there, right? Okay, so a milliliter is a small amount. In the lab, we will use milliliter volumes, right? Normally between like 5 and 50 milliliters, okay? Because that's a convenient amount to use. So, mass, once again, measured in grams, and we can use all these same prefixes, right? Kilograms, we talked the other day about measuring your mass in kilograms instead of pounds, okay? Now, which one of these units is bigger? What does mm and cm stand for? Mm is millimeters and cm is centimeters. Which one's bigger? Centimeters. There's only 100 centimeters in a meter. There's 1,000 millimeters in a meter, right? All right, what about kilogram and centigram? Which one's bigger? All right, think about it. How's a kilogram related to a gram? Is it bigger or smaller? It's bigger. It's 1,000 grams in a kilogram, right? What about a centigram? It's smaller than a gram, right? It's only 100. There's 100 centigrams in a gram. So a kilogram, way bigger. Milliliter or microliter? Milliliter's bigger, right? Micro is the smallest unit I asked you to know, isn't it? Okay? Now what does that K stand for on D? KL. Kilo, right? That's a big number. MC is micro. That's a really, really tiny number, isn't it? So which one's bigger? Kiloliters are bigger, right? Now, what we're building up to is writing equalities and conversion factors, because we're going to start to do conversions on Monday. Oh, man. What we're really talking about is all the stuff that we just did with equalities. They all had equal signs in there. Two things are equal. Have you guys ever done anything? This is how in the last class. Have you ever used any equalities in your daily life? Do you use equalities in your daily life? What do? Anybody buy gas? Anybody ever bought gas? Do you use an equality when you buy gas? You agree to pay $1.79 or something for a gallon of gas. I'm going to trade you $1.79 for 1 gallon. So we agree that 1 gallon equals $1.79. You're using that, aren't you? And you can calculate based upon how many dollars you have, how much gas you can buy, can't you? If you have $20, you can figure out how many gallons of gas you can buy. Who can do that? You should be able to, right? And then if you know the mileage on your car, you can figure out how far you can drive on $20, right? People in the other class said, no, we don't do that. I said, why not? So I said, I'm never going on a trip with you. We'll be stranded someplace, right? So when you go on spring break, you got to know how much money it takes to save at the end so you can get back home. Because if you spend it all at the bar the night before, you're not going to get home, are you? You got to know the price of gas and how much mileage you have. And we're going to write equalities, and we're going to talk about how to do some calculations like that, starting on Monday. Okay? So we're not finished with chapter 2. We'll finish, might be Wednesday before we finish chapter 2. Okay? Fair enough? All right, you guys have a great weekend. Enjoy the lovely weather we have coming.